I want you to take a second and just picture the moon.
Classic night sky view.
Right, exactly. You step outside on a clear night, you look up, and there it is. It's this familiar, glowing, silver orb that has looked exactly the same for your entire life.
Yeah, it never really changes.
And if you're like most people, you probably think of it as this completely dead, silent piece of rock just floating there in the dark. I mean, it is the ultimate symbol of stillness.
It really is a peaceful image.
Nothing changes, nothing moves. It's just a permanent frozen fixture in the night sky.
Which is the exact image most of us have grown up with. You know, you look at the craters through a telescope or even just with a naked eye, and you naturally just assume all the impacts and volcanic activity that formed those features happened billions of years ago.
Right, like ancient history.
Exactly. We treat it like a fossil.
It feels like a museum exhibit, just suspended in a vacuum. But our mission for this deep dive is to completely shatter that illusion for you.
We're definitely going to ruin that peaceful image today.
Oh, totally. We are pulling from some really incredible notes based on a fascinating Patreon post titled Moonquakes Detected on the Moon, and scientists believe they conceal something beneath its interior.
It's a fantastic breakdown of the research.
It really is. And what we are going to uncover today is the absolute surprising geological violence that is actually happening right above our heads. So, okay, let's unpack this. Because to understand what is really going on up there right now, we actually have to rewind a few decades to the Apollo missions.
We do, yeah. Because the opening context here is really all about that Apollo legacy.
And looking at the physical hardware we left behind.
Right. When the astronauts went to the moon, they didn't just, walk around, collect some rocks, and plant a flag.
Yeah.
A massive part of their objective was to leave scientific instruments behind.
To keep studying it after they left.
Exactly. Specifically, they deployed a series of seismometers across the lunar surface during several of those Apollo landings.
And just so we're totally clear, these are essentially the exact same types of devices we use here on Earth to measure earthquakes.
Right. Yep, exactly the same concept.
Just instruments designed to measure vibrations in the ground.
Precisely. They are highly sensitive instruments designed to detect seismic waves traveling through the crust.
Yeah.
And, well, the prevailing thought before Apollo was that the moon was entirely geologically dead.
A completely inert rock.
Right. But the data those seismometers beamed back to Earth over the next several years, it absolutely upended our entire understanding of our closest neighbor.
It changed everything.
It really did. They proved definitively that the moon is not an inert, dead body. It is, in fact, highly geologically active.
And when you say active, we need to be very clear that we are not talking about a little tiny microscopic vibration that only a highly calibrated machine can feel.
Oh, no, not at all.
The facts we have in our source material are staggering. These lunar earthquakes, or moonquakes, can reach up to a 5.5 on the Richter scale.
Which is a very serious event.
Right. I mean, if you experience a 5.5 magnitude earthquake here on Earth, you aren't just sitting there wondering if a heavy truck drove by.
No, you're taking cover.
Exactly.
Right.
Things are falling off your shelves, the plaster is cracking, the walls are shaking. It's a very real, very frightening event that can cause structural damage. But here's the detail from the sources that absolutely blew my mind.
The duration.
Yes, and I actually have to push back on this time frame for a second because it seems impossible to comprehend. The notes state that these moonquakes can last for more than 10 minutes.
That is correct. Up to 10 minutes and sometimes even longer.
I am really struggling to understand how that is physically possible. I want you, listening right now, to imagine standing through a 10-minute earthquake on Earth.
It's hard to even picture.
An earthquake here usually lasts for 10, maybe 20 seconds. 30 seconds is considered an incredibly long, devastating quake, and it feels like a lifetime when you are in it.
It feels endless.
So 10 solid minutes of continuous, violent shaking at a 5.5 magnitude is an absolute eternity. How does the ground even sustain a vibration for that long without the energy just dissipating?
It really is hard to wrap your head around, especially because we are so used to how the Earth behaves.
Yeah.
What's fascinating here is that the sheer duration of these quakes isn't just a terrifying statistic for future astronauts.
It's not just a scary number.
Right. For scientists, that extended shaking is the literal key to understanding the hidden interior of the satellite. To answer your question about why it lasts so long, it comes down to water.
Water? On the moon? Wait, I thought the whole point is that it is a dry rock.
Exactly. Think about the Earth. The Earth's crust is full of moisture. We have oceans, groundwater, aquifers.
Right, water everywhere.
And that water acts like a massive planetary shock absorber.
Yeah.
It's literally a sponge. When an earthquake happens here, the seismic energy travels through that damp, fractured crust, and the moisture dampens the vibration.
Oh, I see.
Yeah, so the energy dissipates relatively quickly, usually in under a minute. The moon, however, is bone dry. Its crust is rigid, cold, and completely devoid of liquid water that act as a dampener.
So there's nothing to absorb the shock.
Exactly. So when a seismic event triggers, the moon essentially rings like a bell.
Rings like a bell. That is a wild image.
The acoustic energy has nowhere to go. It just echoes and bounces around inside the rigid structure of the moon for 10 minutes.
Just continuously ringing.
Yeah. And the way those seismic waves travel, how they reflect and refract off different layers of rock while the moon is ringing, well, it gives scientists a precise window into what is actually inside.
So the earthquake itself is the tool they use to look inside.
Right. It acts like a planetary ultrasound.
Okay, that makes complete sense of the how. But if the interior structure is allowing these massive, incredibly long-lasting tremors to ring out, we really need to look at exactly what is triggering them in the first place.
You have to find the source.
Right, because you don't just get 10 minutes of a 5.5 magnitude planetary ringing for no reason. Something has to strike the bell.
You are exactly right. You have to look at the anatomy of these events. When scientists first started analyzing the squiggles on the Apollo seismic data, it looked like a chaotic mess.
Just random noise.
Yeah. But over time, they began to sort the data and realized they were looking at very different types of triggers. NASA's official moonquake website actually distinguishes 4 very specific types of moonquakes based on their origin.
And I want to avoid just reading these off like a grocery list, because the way scientists had to play detective here is fascinating. Let's start with the most obvious one.
The meteoroids.
Right. When you have a giant rock floating in space with no atmosphere to protect it, things are going to hit it.
Yes, the meteoroid impacts. That is one of the 4 types. Because the moon has no atmosphere to burn up incoming debris, rocks from space smash directly into the lunar surface at tens of thousands of miles an hour.
Which has to cause a massive shockwave.
It does. These generate massive, sudden surface vibrations. They show up as very sharp, random spikes on the seismometers.
So that is an external attack. But the source material notes another type of shallow quake that is triggered by something much more subtle, yet incredibly violent.
The thermal quakes.
Yes, they call them extremely shallow moonquakes, and they are caused purely by drastic temperature changes between the lunar day and the lunar night. I really want to focus on this for a second because the physics of it are so strange.
It's extremely alien to us.
When I was reading this, the best analogy I could come up with is your house. You know, when it is a really cold winter night, the temperature drops rapidly, and suddenly your house just starts creaking and popping.
Oh, definitely.
The wood and the materials are contracting because of the cold. Is that essentially what is happening to the surface of the moon?
It is a good starting point for the concept of thermal stress, sure, but we have to dramatically scale up the violence of the environment.
Because there's no air.
Right. Your house is protected by the Earth's atmosphere, so the temperature drops gradually over hours. The moon has 0 atmosphere. It is a vacuum.
So there's no buffer.
None. So the temperature shift isn't gradual. When the sun sets on the moon, the surface temperature plunges from a boiling 250 degrees Fahrenheit straight down to minus 208 degrees Fahrenheit almost instantly.
Oh, wow. So it is not a slow chill at all.
Not at all. It is less like a house creaking in the winter and more like taking a boiling hot glass out of an oven and immediately dropping it into a deep freezer.
The glass shatters.
Exactly. The thermal shock is immense. The rock on the surface expands violently under the searing heat of the sun and then contracts violently the second it plunges into darkness.
Just snapping back and forth.
Yeah, this causes the actual crust to snap and pop, generating these shallow rhythmic moonquakes every single lunar morning and lunar evening.
That is incredible. So if we connect this to the bigger picture, the moon is not this serene floating pearl.
Far from it.
It is constantly being battered from the outside by meteoroids, and its very surface is snapping and popping every day and night just from the extreme temperature swings.
And that is just what is happening on the very surface. The most profound discoveries come from what is happening deeper inside.
The internal triggers.
Right. Because while the surface is reacting to the sun, the deep interior of the moon is dealing with its own thermal crisis. It is losing its primordial heat.
Right. This leads us to the next trigger. The cooling moonquakes. And out of all the forces beating up on the moon, it turns out that this internal cooling is actually doing something drastic.
It's a huge structural issue.
It is physically changing the overall shape of the moon.
It comes down to basic thermodynamics. The moon was formed in a highly energetic, molten state billions of years ago.
It was basically a ball of lava.
Yes. And it has been slowly radiating that internal heat out into the freezing vacuum of space ever since. And, well, as any material loses heat, it contracts.
The numbers in the sources on this are wild. As the moon has cooled, its internal contraction has caused its overall diameter to shrink by about 50 meters, or roughly 150 feet, over the last few hundred million years.
Which is a measurable, significant change.
Yeah, now 50 meters might not sound like a lot when you're talking about a whole celestial body that is thousands of kilometers wide, but the physical reality of that shrinkage is intense.
It's devastating to the surface.
It creates immense stress in the lunar crust. The crust doesn't just smoothly shrink to fit the new, smaller core, it fractures.
It has to break somewhere.
And those fractures form what are called thrust faults, which actually show up on the surface as these small stepped cliffs. So here's where it gets really interesting. I have to ask, based on this, is the moon essentially wrinkling as it shrinks, like a grape turning into a raisin?
That is an excellent visual, yes.
Right.
The core of the moon is shrinking, but the outer crust is rigid, solid rock. It is brittle.
Can't just stretch out.
No, it cannot stretch or bend to accommodate the fact that the sphere beneath it is getting smaller. So as the interior shrinks away, that brittle crust has to compress.
And it just pushes against itself?
It is subjected to massive compressive forces until the rock finally fails and breaks. When it snaps, one section of the lunar crust gets violently pushed up and over the adjacent section.
Oh, like two tectonic plates ramming into each other, but driven by a shrinking core rather than floating on magma?
Exactly. That overlapping break is what a thrust fault is. It creates a physical step, a cliff on the surface.
A physical wrinkle.
It is literally a wrinkle made of solid rock. And this isn't just some ancient geological history lesson.
Yeah.
In 2019, NASA scientist William Steigerwald stated that analysis of orbiter images provided the first definitive evidence that these faults, these wrinkles, are still active.
Wait, so the moon is actively shrinking, cracking, and creating new cliffs right now as we speak?
Yes. The cooling and contraction is an ongoing, continuous process.
That's amazing.
The crust is constantly building up stress. And every time the rock can't take anymore and one of those faults slips, you get a massive moonquake.
But the moon isn't just reacting to its own internal temperature dropping, right? I'm struggling to picture how just cooling off accounts for everything.
It doesn't. There's another huge factor.
Because the sources mention a fourth type of quake-deep moonquakes, hundreds of kilometers below the surface. If the moon is cooling from the outside in, why is the very center rumbling? What is physically acting on the deep interior if it is shielded by all that rock?
That is the brilliant question scientists had to answer. And the answer is us.
Us? You mean Earth?
We cannot ignore the Earth's role in this geological violence. The Earth's gravity plays a completely decisive role in lunar seismicity, particularly when we talk about those deep moonquakes.
Because of gravity?
Yes. This all comes down to tidal forces.
The sources note that the Earth's mass is about 80 times greater than the moon's. So what does this all mean? How does that massive 80 times weight difference practically yank the moon's interior around?
It's a massive gravitational imbalance.
Because when we think of tides, we think of the moon pulling on our oceans, making the water rise and fall. We don't usually think about how we are pulling on the moon's solid rock.
And that is a common misconception, that tides only affect water. Gravity affects mass, regardless of what it is.
Okay, so it pulls the rock.
Right. It is a phenomenal cosmic tug-of-war, but it is not a simple back-and-forth pulling. Because the Earth is 80 times more massive, its gravitational grip on the moon is immense. But the moon's orbit around the Earth is not a perfect circle.
It's an ellipse, right?
It is an ellipse, so sometimes it is closer to us and sometimes it is further away.
So the gravitational pull gets stronger and weaker depending on the time of the month.
Exactly. Imagine holding a tennis ball in your hand. If you squeeze it, the rubber distorts. Now imagine slightly releasing your grip, then squeezing it again over and over while the ball is spinning.
Just constantly kneading it.
Yes. As the moon moves closer to the Earth, our massive gravity physically stretches the solid rock of the moon, distorting its shape. As it moves further away, the rock relaxes.
Wait, really? So the solid rock of the moon is actually bulging out towards the Earth and then relaxing?
Yes. The solid body of the planet is physically stretching and compressing by several inches every single orbit.
That is wild.
This constant squeezing and kneading of the moon's interior creates massive internal friction and stress deep within the mantle.
And eventually something has to give.
Right. Eventually, that stress hits a breaking point deep inside, which triggers those deep moonquakes hundreds of kilometers down.
That is terrifying and amazing at the same time. The Earth is literally reaching across space and massaging the moon's core until it cracks.
It's a very violent relationship.
And scientists have actually been able to map these scars, right? They're tracking exactly where this cosmic tension is doing the most damage to the lunar surface.
Yes, the mapping is where all these pieces finally come together. There was a major study led by Thomas Waters from the Smithsonian.
Looking at the old data.
Right. He and his team went back and reviewed the original Apollo seismic data collected between 1969 and 1977. But they used modern advanced algorithms to precisely locate the epicenters of 28 specific shallow surface moonquakes.
And what do they find?
They found the smoking gun. Several of these powerful quakes happened right near those visible thrust faults we were just talking about.
The stepped cliffs. The wrinkles from the shrinking.
Exactly. The quakes are happening right where the crust is actively breaking from the shrinkage.
Wow.
And it gets even more detailed in the Apollo data. We currently have a satellite orbiting the moon called the Lunar Reconnaissance Orbiter, or LRO.
Taking modern pictures.
Very high-resolution pictures. The images from that orbiter, looking at the shadows cast across the lunar landscape, have identified more than 3,500 of these scarps.
The fault cliffs.
Yeah, these fault cliffs scattered all over the lunar surface.
3,500 active fault lines just waiting to snap. And this is where we have to pivot, because this really brings this whole conversation directly back to you, the listener.
It's highly relevant for the future.
Up until now, everything we have talked about, the ringing bell effect, the deep tidal kneading, the shrinking crust, might just sound like really fascinating space trivia.
Just cool science facts.
Right. But if you were planning a trip to the moon, or more realistically, if NASA and other space agencies are planning to build permanent Artemis base camps there in the next decade, these active 10-minute-long 5.5 magnitude quakes are a massive, life-threatening engineering crisis.
They absolutely are. It completely changes the paradigm of lunar exploration.
You can't just build a house on a fault line.
No. If you are going to build rigid structures, human habitats, or delicate landing pads on the lunar surface, you cannot just treat it like stable, dead ground. You have to engineer for a geologically violent environment.
And think about the physics we talked about earlier. Here on Earth, we engineer skyscrapers to withstand 30 to 60 seconds of shaking using base isolators and dampeners.
Right, highly specialized equipment, just for a minute of shaking.
How do you engineer a pressurized habitat on the moon to withstand 10 continuous minutes of harmonic resonance? The shaking doesn't stop.
It just rings.
It just keeps hitting the structure's natural frequency over and over. It would tear a rigid building apart.
It is an engineer's nightmare. The acoustic resonance alone over a 10-minute period would test the limits of any materials we currently use in spaceflight.
Just shaking it until it shatters.
A tiny microfracture in a pressurized lunar module caused by a 10-minute vibration is a fatal event for an astronaut.
Which introduces a really crucial point from NASA seismologist Renee Weber, which is highlighted prominently in our source material.
About the future missions.
Right. She emphasizes that to assess the actual risk of moonquakes for future missions, to actually know where it is safe to lay a foundation and where it isn't, we desperately need to deploy a completely new network of seismometers on the moon.
This raises an important question. Just how much don't we know?
Exactly.
Think about what we've based this entire conversation on. We only know about those 28 shallow surface quakes, and we only understand the deep quakes based on data from a handful of Apollo landing sites.
Just a few specific spots.
Right, on the near side of the moon. The LRO photographs show 3,500 fault lines, but we only have seismic sensors near a tiny fraction of them.
Right, all the Apollo missions landed relatively close to the lunar equator on the side facing Earth.
Exactly. So how much of the moon's current violent activity is entirely invisible to us right now? What is happening on the far side?
The dark side.
Yeah. What is happening at the lunar South Pole, which is exactly where NASA wants to land the Artemis astronauts because of the water ice hidden in the craters?
We have no idea.
Without a new global network of modern seismometers spread across the entire body of the moon, we're essentially blind to the true scale of the moon's internal chaos.
We are planning to build a house, and we haven't even checked if it's sitting on a fault line. It completely changes how you look at the night sky.
It really does.
The next time you step outside and see that glowing silver orb, you aren't looking at a silent, dead museum exhibit. You are looking at a highly dynamic world that is actively losing its ancient heat, shrinking inward.
Cracking under the pressure.
You are looking at a brittle crust that is fracturing and snapping, creating cliffs in real time. And you are looking at an interior that is violently vibrating for 10 solid minutes at a time, locked in an eternal gravitational wrestling match with the very planet you are standing on.
It is a phenomenal shift in perspective. It goes from a symbol of stillness to a theater of extreme geological tension.
And it leaves you with a thought I really want you to mull over today as you look up at the sky. If our closest, most familiar, seemingly dead and silent companion in the night sky is secretly harboring this much geological violence and activity beneath its surface,
What else is out there?
right, what other seemingly quiet, frozen moons and planets in our outer solar system are hiding highly active, churning, violent interiors, just waiting for someone to drop a seismometer on them?